studying for our quiz tomorrow, I'm going to give you 5 problems, just 5 to study for the review, and your quiz is going to look just like that, just 5 problems, okay? When you get this, and I'll write this on the board again, you need to find these things. You need to find the zeros. You need to find the vertical asymptotes, horizontal asymptotes, end behavior, removable discontinuity, and discontinuity. Okay? We're going to find those 6 things. Next week, we're going to add a 7th with oblique asymptotes. Okay. So, if we look back at our definitions, which you might need to do, what are zeros? Can somebody tell me? I only had like 2 or 3 people say they were having trouble with zeros. So you guys remember what zeros are?
Set the numerators equal to 0.
Set the numerators equal to 0. So we can have x plus 5 equals 0, and x minus 1 equals 0, and we're going to get negative 5 and positive 1, right? Okay. Anybody have a question about zeros before we go on? Because just think of like, I'm not saying this is what it's going to be, but it's probably going to be something like that. Think of all 6 of these as being 1 point. Okay? So let's say that each of these on your quiz are 1 point. So just as we're going over this, think how many points you think you would get for this problem. Okay? All right. So do we think we can get the zeros?
Yes.
All right. Vertical asymptotes. What are my vertical asymptotes here? 2 and negative 3, right? Make sure you put x equals 2 and x equals negative 3, because they're lines. Okay? Who feels like, you guys feel good about vertical asymptotes? So zeros are setting the top equal to 0. Vertical asymptotes is setting the bottom equal to 0. Okay. Horizontal asymptotes. So I go back to my notes each time I do this. This is why I'm going to let you have it on the board. And let's talk again about those horizontal asymptotes. Okay? So I'm putting a little note to the side, horizontal asymptotes. I'm going to put it in a little box. Little note to myself at the side. I've got, if my degrees for my numerator are smaller than my denominator, my numerator equal to my denominator, and my numerator greater than my denominator. Okay? Again, remember this is going to be on the board. If numerator is smaller than the denominator, y equals 0. If numerator equal to denominator, it's the leading coefficient over the leading coefficient. If numerator is greater than denominator, no horizontal asymptote. Okay? N equals the numerator's degree and D equals the denominator's degree. Okay? All right. So, what is this one? How many exponents do we have on the top?
2.
We have 2, right? Because it's 1 here and 1 here. What about on the bottom?
2.
So are they equal?
Yes.
Okay. So it says leading coefficient. Do we have any numbers in front?
No.
So what is my leading coefficient then?
X. No, not
1.
1. Wait. Oh.
Okay, if I say x, you know that really means 1x, right?
Yeah, I know that.
So that's the same thing here. Okay. All right. Now let's talk about, so besides horizontal asymptotes, end behavior is absolutely the thing that you guys are struggling with the most, according to our little survey. So, remember, end behavior always starts with x approaches infinity, y approaches something. X approaches negative infinity, y approaches something. Okay? So everybody can write that down and they get half a point. Right? So the next part is figuring out what y is approaching. If the horizontal asymptote is 1, then they're both approaching what? 1. Done.
Locates a lot, bro.
Okay. Is there anything, this is for one problem. Is there anything on the top or bottom that can be removed?
No.
So, what is the removable discontinuity? None. 1 point. Right? Discontinuity. So, I'm going to write this little note to myself right here. Discontinuity is all the removable discontinuities and the vertical asymptotes. So discontinuity should be really easy because you're literally just writing things again. So there's nothing under removable discontinuity, so I don't have to write that down. What's under vertical asymptotes? 2 and negative 3. And I'm finished. Okay. So, I did most of this one. I want your help. I want volunteers for all of these for this next one. You ready? Okay. Okay. So, let's look at this one. Miss Murphy speaking. He already left to go there, so, yep. Yep, bye. Okay, so let's do number 2. Okay, you ready for this? We've got x minus 1 times x plus 2 all over x plus 2 times x minus 3. Okay, this is what f of x equals this function. Okay, so we're going to find zeros, vertical asymptotes, horizontal asymptotes, end behavior, removable discontinuity, and discontinuity. Okay, raise your hand if you want to tell me what the zeros are. Jordan.
Positive 1, negative 2.
Okay, raise your hand if you want to tell me what the vertical asymptotes are. Go ahead. Negative 2 and positive 3. And remember, you need x equals for these. Yes, it's the denominator for them. Okay. Now, who wants to try horizontal asymptotes? Go ahead, John. Shh. Okay, so horizontal asymptotes, first of all, I know that there is the equal number of x's on the top or the bottom. So that means we go to the leading coefficient, and the leading coefficient for this is 1, so it is y equals 1. Beautiful. Okay. So I've got x approaches infinity, y approaches something, x approaches negative infinity, y approaches something. Okay. So, what is the end behavior? What is y approaching? Go on. 1. Beautiful. 1 for both of them. Okay. Removable discontinuity. What can I remove? So, x equals 2, or 2. And it's actually negative 2, right? Okay. Because it's the opposite. All right, discontinuity, what do we got? We've got negative 2 and 3. So I removed negative 2 here. So I'm going to go back to my vertical asymptotes and my zeros, and I'm going to remove them. Right, because it's a removable discontinuity, so I can remove them. Do you see how that worked? I removed this, so I went and removed them from my answer. Good? All right. We're going to try another one. It's going to have one extra step to it. Okay. Oh, everybody freak out, please. Okay, ready? Here we go. So I'm going to say f of x, this is problem number 3. Shh. I've got x squared plus x minus 2 over x squared minus x minus 6. What do I need to do first? What do I need to do first? Factor. So what does it factor to? Let's draw that box. Shh. So we've got x squared and we've got negative 2. So we know we've got x and x. What two things multiply to give us 2? There's only two things. 1 and 2. I have a positive answer here, which means which one of these needs to be positive? The 2. The 1 is negative. We know this adds to give me 1. Okay, so the top became x plus 2 times x minus 1. Now let's look at the bottom. Okay, we've got x squared, we've got negative 6. That would not give us negative 1. What else multiplies to give us 6? 3 and 2. So we've got 3 and 2. We've got a negative answer, which means which one of these has to be negative? The bigger one or the smaller one? The bigger one. The bigger one. So that we get 2x and negative 3x. When we add them together, we get a negative 1. Okay, we have factored it. We've got zeros, vertical asymptote, horizontal asymptote, end behavior, removable discontinuity, and discontinuity. Who wants to tell me what my zeros are? Okay. What's my vertical asymptotes? Remember, it's x equals negative 2 and x equals positive 3. What's my horizontal asymptote? Y equals 1. What's my end behavior? As x approaches infinity, y approaches, x approaches negative infinity, y approaches 1. What's my removable discontinuity?
2. Negative 2.
Negative 2. So remember, take out your 2's right away. Shh. Thank you. Gentlemen in the back, this is why I didn't want you to sit there. Shh. Okay. What is my discontinuity then? Huh. Do they look exactly the same? Because one is the factored form and one is not. So once you factor it, it should be just as easy. All right. So, do you want to try one more, or you guys want to do your homework? Okay, let's get the homework.
Done.